folks.
Hey, everybody.
Welcome to Substrate Seminar. I'm Lauren.
And I'm Aaron.
And you're joining us. We didn't plan what we were going to say next.
That's as far as we got for today's stream. See y'all next time.
Thanks for joining. Oh, I'm so excited for today. I think it's going to be awesome. A really cool conversation. Some really wonderful folks are joining us. So let's bring them in.
I thought it was Joshy and Andrew.
It is, and I really love them, so I can't wait to see them. Let's bring them on stage.
Okay. Hello, everybody.
Hey, great to see you guys again.
So long.
So happy to have you both joining. Andrew, unmute yourself. Let's go. Hi.
I was trying to give you the silent treatment for that quick little diss that you threw. Yeah. It's all business today.
I know. I am, stoked beyond because the four of us originally became friends at the last wave of PBA, which is Polka Dot Blockchain Academy, which we spoke about many times on this channel, but it is a quite intensive program to learn all things about the polka dot ecosystem and blockchain in general. And these two were our teachers.
Yeah, and the Polka Dot Blockchain Academy was bringing us together even before that wave where we met you two, because Andrew and I met each other previously at the first wave back in Cambridge.
And look at you now.
I know, and so that it's like a
he couldn't get rid of me. He tried, but like a tail.
It brings people together and inspire. Who had the idea? Like, did you have the idea in your brain and then you were searching for a partner, looking for Andrew?
Good way to make an assumption that Joshy started this whole thing, by the way.
Yeah, why?
I think he did.
I'm the one sought after. Yes.
It was a team effort. It was a team effort.
Okay.
Yeah, you tell it.
I think we had some similar aligned interests, and then we were brewing ideas. Actually, what we're going to talk about today has been brewing since the first PBA in Cambridge, and it's been brewing actually at Parity before that, but it's iterated. So
I love an origin story. So yeah, let's tell that today.
Joshy has the whole history.
Yeah, I'll tell the first chapters as far as I know them. So I started at Parity. I'm not at Parity anymore, but I was, and I started there in 2019. And Substrate was like brand new. There was no Polkadot or Kusama or anything. Right. There was just some testnet, and I started like right when they released the 1.0, I guess. And there was this project that this guy Dimitri put together, which was the Substrate UTXO workshop, where he wanted to build something kind of Bitcoin like basically a simple cryptocurrency that was based in the UTXO model. And it was really cool in many ways. And it was also really limited in other ways. He actually built it inside of a Frame palette, which isn't really the right place for a UTXO system because Frame is kind of accounts based. But most of the core ideas were there. But anyway, me and a few others maintained that project over the years and made it like more true to Bitcoin in many ways, but we always sort of had it crammed inside a Frame palette. And then when we were in Cambridge at the PBA, I suggested this final project assignment that was to take that thing and that UTXO workshop and get rid of Frame and make it a standalone runtime. And so that's where Andrew got involved.
And Andrew, was that your final project?
Yeah, and then I was the only one who did it.
That's right. There were like 50
people.
There were like 5 options.
It wasn't Joshy fighting through the stack of candidates. It was like, here's my person.
For me, it was interesting to. Yeah, go ahead. Sorry.
I was gonna say, did you pick that project because you knew that like that was Joshy's pet project and you just wanted to suck up a little bit on your assignment, make yourself a good mark? Is that how it worked?
Yeah.
I think no.
It's very manipulative and political.
Where's this narrative coming from?
Yeah, I don't know. Like, why are we pushing this?
I am not that devious. No, what was interesting about it is that that project had been in the old Frame, which was not very fun to deal with. But anyways, it really involved ripping out Frame and dealing with just Substrate. And since we're talking about Substrate, I was really, Frame does abstract a lot of stuff from you as the Substrate developer. I would say that like Frame developers at Parity are kind of like the pinnacle Substrate developers, since it's kind of layered. And I really wanted to go down a layer. And so this kind of gave me the opportunity to do that.
Yeah, to get your hands dirty with it. That's so awesome. But I love it. That's really, it's neat to hear about like where your interest began and then now where it's evolved too. And it's a great shout out to opportunities that can come for students of the program and relationships that can be built into turn into, you know, working relationships. So I love it. I think it's a really beautiful use case story, in fact, actually. So, but we should also say hello to folks that are in the chat. Thank you for joining us today, and we're really happy to have you here. So we want to hear your questions, want this to be as interactive as it possibly can. So please, please, please ask in the chat, and we will pull your questions up, or if you just want to say hi or troll these two.
Yeah, if you just want to send Andrew like hundreds of applause. There we go. Oh, wow. Wired and Cod, you beat me to it. Like I knew that was going to come at some point today.
We really like to applaud Andrew, and he deserves it.
Yeah.
We're rooting for you, kid.
Clap. I can't send the clap emojis, but I can just do it right on the screen.
Sure, totally. Okay, so. Oh, wait, we should also, I think you have a slide about this, but we should also talk about the origin story of Substrate Seminar, Joshy, and the fact that.
I do, yeah. So
Okay,
let's,
yeah.
you want to flip the slide up and we can tell that joint
That's good.
story as well. Yeah. Let's see. Is it showing?
It's showing, yeah. There you go.
Okay. So this is just my title slide. So this is what we're going to be talking about, Tuxedo. This is the project Andrew and I are working on, but there's these few like intro before we kind of get into the content. So Substrate Seminar, that's the call you're watching right now. I mentioned earlier I started at Parity back in 2019, and Substrate Seminar was one of the initiatives that I had started up. And back in those days, it was just a Zoom call where anyone could join and anyone had a hot mic, and we would like record it and post it on YouTube later. And then it went through some migrations while I was still running it. We switched to Crowdcast, and it kind of, changed the character because it wasn't the case anymore that anyone could talk any moment they wanted to, but it also did kind of manage a like growing like crowd basically. So I personally like to have the interaction. So please, comments and questions in the chat or however you can reach us are very welcome. So anyway, after I left Parity, Seminar got handed around a little bit, and there's been a couple people who have hosted it and done a really nice job, and I had come back to present a few times, and I saw at some point it got migrated to Twitch, so this is the first time I've been on the Twitch stream. And then Lauren and Aaron, I wanted to ask you guys, are you guys here like just this time, or are you kind of the new
No, we're gonna we are.
I won't be here every time.
Moving forward, you just wanted to
I just wanted to join because it was you, y'all.
Yeah, because it's the two.
Oh, yeah. Oh, nice. So I'm glad you're here. Thanks for coming.
Yeah. But I probably will pull you in. It's pretty easy too. I can just grab you and have you come in. But yeah, so moving forward, but we'll continue it here on Twitch to see if we can like engage audience and bring folks in. That's the whole point of doing it live, is so that people, as you said, like can be interactive, maybe not always sharing a hot mic, but
always clapping for Andrew.
Okay, yes, exactly. But that's our goal. So, but that also depends on the community and the audience, and that folks want to be a part of it and see it. And so, yes, continuing it to be topic driven by community is number one for me. That it's not me and Parity saying like, these are topics that are important to developers. Like, I'm not going to assume that I'm not going to be the voice of that. So y'all in the audience, please let us know what you would like us to be talking about.
All right. Well, shall we dive in?
Let's.
I think we should, yeah.
All right. Sounds good. So we sort of introduced ourselves a little bit, but this is, I'm Joshy. I'm the one on the right there. And then that's Andrew, the peace sign. And when we put our rings together, we become Off Narrative Labs. So this is like our GarageBand dev shop that we started for this Tuxedo project. And so the links to our GitHubs are here, and it's just occurring to me that you guys should have the link to the slides so you can flip through them with us. So
yes, we're going to put that in the chat right now.
Yeah, perfect. All right. Way to go. And okay, so yep, so that's us. We're now working together as Off Narrative Labs on this project Tuxedo, which is, as the title slide said, all about writing UTXO based substrate runtimes. So there's a decent amount to unpack there. We're going to assume some familiarity with Substrate, but we're going to like go over the key distinction, like the APIs in Substrate, and then we're going to talk about what the UTXO model is, and then in the later parts of the seminar we'll get more into code.
Cool.
So yeah. Okay, so Tuxedo was funded through a Web3 grant. We linked our application here, and it sort of lists the specifications of what we're building. And so there's 3 milestones, and the first 2 milestones are accepted and completed. The first one was just to build like the core UTXO framework, the main chunks of Tuxedo. Second one was for a template wallet, which can be extended for individual like decentralized applications or like user applications. And then the third milestone is the one we're just getting started on. And actually this seminar is kind of going to serve as like a dry run or beta test for the third milestone.
Exactly. What
which is
you
the full
receive,
tutorial.
like what does it make sense narrative wise? Does it, all of the how to help people build.
Sorry, what was that?
Just that it's like this is the workshop moment for you to think about how to help people build it, right? Like how
exactly.
Is this the right way to be telling the story of how to go from zero to hero in the sense?
Yeah, exactly. So to everyone who's watching now, you get to come along with us. We're going to talk some theory, we're going to talk some examples, and then we're going to dive into the code. And then we'll either take the code we write today and directly turn it into this tutorial, or more likely we'll clean up all the spots we tripped on and then turn it into a better tutorial. So
awesome.
You get to be part of the process.
Yeah, so it's extra important then if you do have any questions, folks in chat, or anything that you don't quite understand or something you would like clarified, like really bring it up now, because you could have a major impact on the documentation for Tuxedo going forward.
Yep, absolutely. Absolutely. Okay, so this is my latest rendition of the Substrate architecture slide. I think everybody, probably the 4 of us and everybody who's worked like adjacent to Substrate docs, has probably drawn several versions of this. And
sure.
I actually have one tattooed on my back. So
yeah, oh yeah, very nice.
Get it modified then.
So, some of them are so old they like feel like overplayed songs, and some of them are licensed, and I just wanted to make my own one in the white on black colors. But so this is the diagram of a Substrate node, and there's many distinctions and pieces we can talk about, but the main one that I want to talk about today is sort of the biggest one, which is the client versus runtime distinction. And so you can see the runtime is here. That's WebAssembly program. And it gets executed by the client. Everything else here is the client. So all of this, the client is basically like a normal program, runs natively on your computer, and it handles all this general purpose blockchain administration stuff. So communicating on the P2P network and answering RPC requests, ordering and prioritizing and validating a transaction pool, and managing the database and all that stuff. Yeah. And the thesis of Substrate is that these client-side tasks should basically be reusable among almost any application blockchain. And then the runtime is sort of like your specific application. So so that's the distinction. And then when you draw a boundary like this, you have to say like, okay, well, what's the API at this boundary? And so there's these things called runtime APIs. And a runtime API is a way for the client, the main Substrate node program, to call into this dedicated application, the runtime. And there's a whole bunch of these runtime APIs, but there's only 2 like really important ones, and all the rest are sort of like intermediate to advanced knowledge. So I'm just going to talk about these 2. Yeah. And the first one's the core API, and that's for executing arbitrary blocks. So think of yourself as a blockchain node, and you hear from one of your peers this message that says, hey, I got a new block, or I heard gossip about this new block. Execute it and add it to your chain if you find it valid. That's what this API is for. So you can just, or maybe you load a block from disk and execute it and add it to your chain if it's valid. Sure. So that's what the core API is for. And then the next one is the block builder API. And so this is for when you're an authority node. So either like a miner if it's proof of work, or a validator if it's proof of stake. And you use this API to author blocks. And so it's not a single API call. You basically call initialize once at the beginning of the block, and then you apply 0 or more, but typically a whole bunch of extrinsics, and then you finalize the block, and that's how you build it.
Yeah.
So those 2 APIs are the ones that I'm choosing as kind of representative of what the boundary here around the runtime looks like. And then just as a reminder, there's others that are in there as well.
Okay. Yeah.
So the reason that I'm pointing these APIs out is because our task right now is to write a runtime. And the typical way to do it is with Frame. But Frame does a lot of the heavy lifting for us. And so if we want to do it from scratch, we need to go all the way down to the API level and implement those APIs ourselves directly. So our job is to implement these 2 APIs and a few others, but essentially these 2 sort of most important ones.
And so why would a developer want to remove that abstraction and do it themselves? Can we talk about that?
Yeah, absolutely. Yeah, very good question. So let me actually show you this next slide that kind of gets at exactly that. So I stole this one from our colleague Sean Tabrizi, who made the video game cartridge diagrams. I added the made with Frame though. So if you think of like the Substrate client as the Nintendo and then the runtime as the games, you've got like Polkadot, which is made with Frame, and all these other ones you've probably heard of, Moonbeam, also made with Frame.
Just a
or then you could
clarification,
do, like,
this is a Super Nintendo, not Nintendo, right? Yeah.
Oh, it's a Super Nintendo. Yeah, you're right. Very good. You have to PR my speaker notes because I have it wrong in there.
Also had to say that is the US and Asian version, not the like European version as well. It looks slightly different than that. Just for anybody who's kind of like tuning in right now.
I just can't believe that's what we're talking about right now. I just have no words. And I just like am thinking about, yes, the moment I said, sure, come join the stream.
Yeah. Lesson learned. This is your first time hosting.
Is this really the most important part that we're focusing on here?
Can I mute you?
Okay, so we were talking about the different runtimes you can sub in, and then this isn't, these first 2 are examples of like production ready ones. You might like buy that game at GameStop or from some serious like game developers. And then this looks like somebody's hobby one, like my first runtime from scratch. And we all well know, having been to the Academy, that this is actually a project you do at the Academy.
Sure.
And you learn a ton, but as you can see, this one doesn't really look production ready. And so that's like, Lauren, you were asking about why would you want to give up these abstractions of Frame? Well, my first answer is an answer to the opposite question of like why you wouldn't. When you use something, when you use something like Frame, you get something that comes out a lot more like this. And when you do it from scratch, you get, something that looks like you chewed on it. And
yeah.
But it's very good for learning. But so what I would say is like, why would you want to move away from Frame is because maybe you can find another framework that will give you something kind of production ready like this, but is built with a better model that better suits your specific application.
Yeah. So that's what I feel like is the key here. So
Yeah. Great. So today we're going to live code on this example chain called the Seminar DEX chain. So we're going to build a decentralized exchange, and you can see this one says made with Tuxedo. So Tuxedo is what we're here shilling today. It's this way to write UTXO based runtimes on Substrate.
Andrew really appreciated your use of shilling there, giggling as you said it.
Yeah. So make sure you star our repo and you'll end up in the Seminar DEX airdrop.
Very cool. Yes. Go right now, folks. Put up their repo so they see it.
Okay.
This is not financial advice.
Yeah, and there's no real airdrop, but you should still star our repo.
Please. Okay, and then we will also talk about though, like why someone would choose the UTXO model, right? Like
yeah.
Okay. Cool.
Yep. Andrew's going to talk about that actually. I wanted to make one more analogy before I let him do that. So if you think about launching your personal blog, if you want to run your own blog for some reason, there's a whole bunch of different ways you could do that. You could use like Gatsby or Hugo or Jekyll, or you could use something that runs on the server like WordPress or Drupal, or you could use a service like Medium or whatever. The end result is always a blog where people read your blog posts. And similarly here, we want to have a rich variety of frameworks like Hugo or Jekyll or WordPress or whatever to write Substrate runtimes, and that will all be compatible with Substrate, because no one of those site generators is the perfect one. They all have trade-offs with each other. And so we're trying to take the first step at creating something other than just Frame to sort of turn the monopoly into like an oligopoly or a duopoly or something, and I think part of what we're doing here is not just the UTXO thing. That's obviously the main part, but I think it's helping people also understand this distinction about like what is Frame versus what is Substrate, where Frame is just a tool for writing the runtime, whereas Substrate is this whole blockchain client.
Yeah.
So, okay.
Yeah, it's
Andrew,
so true. Like verbally, you'll hear people almost like synonymously link them or use them interchangeably, and it's not. And so it's great to now add another so that we can almost like understand the verbiage of it too, to see that they're,
I have to admit, whenever we're doing the like frameless runtime at
that's
PBA,
the exercise I was thinking about.
I remember sitting that assignment going, why am I doing this? When will I ever have to use this? And this is it.
we were making you grind through writing a game that looks like this one.
Yeah, exactly.
So, yeah. All right. So Andrew actually taught the accounts versus UTXOs section at the Academy. So Andrew, do you want to take over?
That's why I don't remember it very well.
Yeah, perfect. So there's kind of a big question we haven't answered yet, which is, I guess we can, we'll talk about it a little bit, but there's some trade-offs versus this like state model that it's kind of referred to, and the two general state models. Now, people have made hybrids between these and done all sorts of crazy stuff, but generally there's this accounts model, UTXO model, and they both have some general trade-offs. And so kind of like what Joshy alluded to is, the point of Substrate is to have diversity of options and choosing of your building, empowering the builder more. And so we just want to add more tools, because as an engineer, we probably, and once you start learning what you're actually doing, you realize, okay, well, if I choose this way, I get this trade-off. If I choose this way, I get that trade-off. So just to tell you a little bit about some of the trade-offs. So accounts, good for reducing state bloat. This is like as your blockchain gets bigger and bigger, more accounts are added, you get this kind of ever-growing thing. Accounts is a lot better at reducing that. I'll kind of show you why. They're not as great for privacy. I'll leave some caveats there. You can do privacy, but hopefully what I show you can let you know why. Because I mean, in the most naive sense, you think, well, why is that the case? And you go, well, I'm reusing this thing over and over. So if I reuse my account for this and I reuse it for that, there's linkability between what I do over here and what I do over here. And that in the privacy world is a little bit of an issue. A lot of an issue. It's also, but it is pretty good for this like general computation model. It fits kind of like really well into that. This kind of like key value kind of primitive that we use all the time in programming. And it's also not that great for parallelization. And I have some diagrams that will show kind of why it is possible, but much more difficult than UTXO. So UTXO is kind of like opposite of the accounts in many ways. So it's pretty dang good for privacy, because you have this way of kind of breaking a single account into multiple different pieces. And it's kind of like a base building block for a lot of the zero knowledge stuff. It's not the only thing that you need, but it is generally a piece. And I'll just make a couple statements about what would be your general layout of the thing you're trying to conceal with zero knowledge generally with UTXOs. Not so great for state bloat, because if you think about, which I guess we'll talk more about UTXO model exactly, but in the accounts model, you really could think of it, if you just think of like a money application, you have a balance. Lauren has a balance of 100. There we go. So in the UTXO model, you have like Bob's balance is actually like the sum of all of his unique UTXOs, which exist in the state. And whereas in the accounts model, Bob just has 10 coins.
Right, but in UTXO, all of those three are all of Bob's.
Bob's,
Bob's, yeah, or associated, whatever too.
We just define UTXO. We keep using the acronym.
Yeah.
Totally.
I mean, it stands for unspent transaction output. I don't know if that really helps. I mean, I guess the simple answer is that in the UTXO model, you have these individual, I guess you could think of them as dollar bills that have your name written on them. And at some point you spend the thing and you get some other piece, some other uniquely identifiable bill that comes out of it, or even the opposite way, you could take a bunch of them and sum them up to one.
Right.
So yeah, it's an output that's not, I think it'll be a lot easier when we go through some more of the code, exactly like kind of how to show it. But this is really what it is. It's like, one is you got an account balance. The other one, you have like a bunch of unique bills with your name on it. That's the kind of best, simplest answer. So we can go to next.
Yeah, I wanted to add too, the acronym UTXO, like Andrew said, unspent transaction output. So like that acronym comes from the cryptocurrency context. So think like, Bitcoin and the early cryptocurrencies, and like, transaction, like, you can almost think of UTXO as just like a word that means this thing that's in state somewhere. And I don't usually think of like what each letter means anymore. It's kind of funny that we forgot to define it because of that.
No.
Yeah, and just I guess not to go too much, but it originally comes from Bitcoin, or at least Bitcoin is the first crypto to integrate it. So, anyways, we can go on.
Yeah, and that's I'm glad we said that, because you will hear people speak of those two together, and so it's important to like have that historical context of it also.
Mm-hmm. Right. An accounts model. So, there's this on-chain logic must be deterministic. Well, there's this idea, I guess, in general with accounts that you kind of have the system or the chain, the runtime ends up being some, it determines some output for you, right? You don't you submit some input to this thing and it doesn't computation and spits you out what it determines what the output actually is. I guess that is all. Anything else you want to add here, Joshy? I mean, that's my general thing.
I think that thing that you said just now about how like in the accounts model, it typically gives you the output is a really, really key idea. So we'll just to go to the next one, like the last bullet point here, like with the UTXO model, the contrasting thing is that it just checks constraints. So in the UTXO model, you have the starting state, you specify like the exact starting state you want this transaction to work on, and the exact ending state that you want it to achieve. And then the changes checks is there some valid path? Like, are all of the necessary constraints met? And if so, then the final state that you proposed is the final state. Yeah. Whereas in the accounts model, like Andrew said, it's more like you start with the starting state and you say, okay, I want to send 10 coins to whatever smart contract. And then the chain tells you, here's the final state. So it's more of a what does the chain figure out the final state, or does the chain just validate that the proposed final state is correct?
Right. So those are really the main kind of, I guess, computational model differences. One, you submit input, you get some output determined by the system, and then the other one, you submit your output, your input with your output, and you say, is this valid? And it needs to do some checking.
And so we're hoping to empower developers to ask that question before build, right? To decide which one is going to be better for them, not to just assume that one, because that's what everything else is already written in. Is that kind of like we're hoping that folks will have that kind of that
exactly
moment. Yeah,
exactly. Because like if you have this genius idea that you want to write in your chain, and you're like, okay, how am I going to express this idea as a substrate runtime? Right now, you only have one tool, which is Frame, and it's accounts based, which is great. Frame is the right tool for many, many jobs, but it's not the right tool for every single job. Sometimes UTXOs are better. And so we're trying to add another tool into the toolbox so that when someone can assess and say like, oh yeah, my design actually works better with the UTXO model. Maybe I'll use Tuxedo instead of Frame.
Yeah,
exactly.
So I guess it's kind of looking at that pros and cons list that we went through like right at the very start, some of the things that accounts model does well, some of the things it does badly. So if you were doing a very privacy focused chain, for example, that didn't need to do an like on-chain computation, then like UTXO model will be a better fit for you than the accounts model.
Yeah, that's a perfect example. When Andrew and I were talking about getting started on this, we looked at Manta, which is a parachain that are going to be a parachain, and they are a privacy coin basically, and they have implemented a UTXOs inside a frame palette, because when they were writing their runtime, frame was the only tool available, and so it might have been that they would have chosen differently if something that was UTXO native was available.
Andrew's like, this feels familiar. So have you reached out to them to be like, hey, take a look? Like,
I hope to. I don't know if you have, Andrew.
No, I have not. No, I have not.
We're doing it right now. This is the moment.
This is the reach out. Yeah.
Hi.
Cool. All right. Well, thank you for explaining. Start our repo. Get in there.
Yeah. And please, in the chat, if we are using language or things that it seems confusing, please let us know in the chat. We're happy to like kind of come back to any of these definitions throughout as well. But this is kind of like foundational, and we kind of need to all agree that this, like, fundamentally we understand while now moving forward, I would say.
I'm just putting this up just so that people know where to go and start.
Oh, sure. Yeah.
Yeah. Thank you. So I wanted, I'll give it back to Andrew in a second. I wanted to dig in on one of these other contrasting points here. So in the accounts model, so many people are familiar with the accounts model, either from Frame or from Ethereum. And when you're writing a smart contract, whether it's a Substrate runtime or like a Solidity contract in the accounts model, you're defining your storage as individual storage items. So you can think about like a balances mapping from address to balance, or any other piece of state you've ever written in a frame palette. And what happens there is when you're giving it a storage name, like the variable name, you're actually, that name is hashed in some specific ways, and that calculates a global address for that storage to live. And so everyone who uses that system knows, like, okay, if I want to know what Joshy's balance is, I just go to this one specific place in state, and that's where Joshy's balance is. And then same thing for anyone else's. But the state works a little different in the UTXO model. So in the UTXO model, there are no global storage locations. So there's nowhere to go in chain to say, like, what is Joshy's balance, or like what attributes does this CryptoKitty have or something. It's all local to an individual UTXO. And so what that means, I think of the UTXO model as like this giant wall of cubbies, and you can put any number of things in all these different cubbies. Sure. And if we're talking about just a cryptocurrency, then what you're putting in there is, like Andrew said, like dollar bills or coins or something like that. But if we start to generalize into, whatever, it could be NFTs, or it could be ballots, or it could be governance related things. And so when you send a transaction, basically what your transaction is saying is consume some inputs. So go to some specific cubbies and pull stuff out of them, and then create some new outputs. So go to new cubbies and put new stuff in them. Maybe the new stuff is made out of some of the old stuff that you took out before. And so when I say that all state is local, what that means is there's no way to know, like, for example, like Andrew's balance, Andrew's cash will be in this one specific cubby. You would have to watch all of the transactions that send the money to Andrew to know exactly where they go.
And so at any given moment, am I able to, and maybe I'm like coming from an accounts like obsessed framework or lens, and so I apologize for this, but like, am I ever able to know just at one moment? Do I have to look at all the cubbies to know what Andrew's account balance is?
So that's a great question. Yeah. So that would be one way. That certainly would work. But I think the concern I hear is like, that doesn't sound very like computationally efficient to check like the entire potential state space. And so that's not the way it's typically done. What typically happens is that your wallet basically watches the chain as new blocks roll by, and it just watches for new coins that are owned by your address, and keeps track of the specific state that's relevant to you.
So for those particular ones that I care about. Oh, we have all this.
Yeah, exactly.
So your wallet is very visual.
Your wallet kind of is a subset of state that's relevant to things that you care about. And like our wallet isn't quite fully generalized yet, but the idea is that when we're done with it, the user will be able to define what's relevant for them. Like maybe it's just their money, or maybe it's their money and their NFTs, or like whatever they care about, basically.
Cool. I love it.
So offloading really the kind of state management then to the client, to the wallet, rather than doing
so that's one thing that's cool about UTXOs. We offload as much as possible off chain. So like we were saying, like the UTXO model is not calculating post states. It's saying, hey, you're the user, you tell me the post state you're looking for. I'm just going to make sure it's valid, which in many cases is a lighter computation to make. So okay, I got us a little derailed, I think. Andrew.
No, that was
No, it's good.
Okay,
it's good. So there, something I guess that's pretty popular at the moment and been for a while is this like sidechain model that a lot of people have considered, right? Which is the scaling solution. And UTXOs are kind of uniquely, they're pretty good at this. I said that it's scalable in this paradigm better than the accounts. And I kind of just want to illustrate it a little bit with a picture so you can kind of see why that is.
Let me make the picture big. Is this the one you want?
Yeah, bigger. Yeah.
Yep. Here it comes.
How's that? Good. Yeah, that's good. So if we kind of look here, we have this like layer 1 blockchain in the top left, and then we have like the layer 2 sidechain down underneath. And I'm showing like a subset of UTXOs, 1, 2, and 3, which are on layer 1 chain, which are owned by this particular address, 0x1234. And so in the kind of like layer 2 sidechain thing, you have like this, you want to do some kind of scaling and maybe do some faster computation on each one of these UTXOs. What's nice is that if you want to create a transaction for UTXO 1 on layer 2, which you see there in the CPU 1 box, and also simultaneously for UTXO 2, you can do this in parallel because there's no dependencies between the two. So even though they are represented by the same account, 0x1234, which I say is me, you're able to kind of like parallelize the computation. So this is nice because I could do a bunch of work on this sidechain related to this one single account on layer 1, and then I can kind of like do this batch transaction then for the L1. So I can do stuff fast and then not violate kind of like these things are all kept independent, even though I own all of the UTXOs on layer 1. Hopefully that makes sense if there's any questions on that. So this is a nice property that I just kind of wanted to show of why this UTXOs is nice for being able to parallelize, because there isn't an interdependency.
Yeah.
If we go to the accounts model, I just want to show, and there's ways around this with accounts too. I don't want to say that it's not possible, but it's just not as easy. And I'll show you kind of one problem that you encounter when you do this. So in the accounts model, we kind of have the same paradigm here, but you have this one address 0x1234 that has a balance of 100. And if I go to the layer 2 sidechain, where I want to have 2 different cores operate on 2 separate transactions that I'm trying to deal with here. Now I have this interesting kind of thing of maybe I want to send 50 in one of them, but then I want to send 60 in the next one. And so if I did that, the result that I would get in the batch transaction at the top would be something that wouldn't be valid because I'd be left with a negative balance. Mm-hmm. So this doesn't just have to do with money, right? Like this is just for illustration purposes. And there's ways to kind of build a dependency graph to get around that. But this is kind of one issue that you encounter, is that it's just not as parallelizable for this kind of sidechain model in many ways. So yeah, this is just kind of something. I also kind of wanted to talk a little bit about just the ZK thing. So what's nice is if you have some amount, this is like kind of a wall of text here, but there's really like, if you think of this kind of naive thing is that what you want to do is you have some UTXOs that represent your balance, some Bitcoins. You might you might want to prove kind of the following at the bottom there, which is like, I want to know that I control a particular key, which can spend some amount of UTXOs, which can sum to 4. If I wanted to prove that I had 4 Bitcoins, and you also want to make sure that the UTXOs themselves are valid and not spent yet, and that they at least have a value of 4 if you were to sum them up. But the thing that we're trying to avoid here is linking the actual like which UTXOs are going to be spent, right? And then also we want to know that, you know, we have this kind of total balance. So I guess what we're trying to say here is that this problem gets a lot more deep, but in general, if my balance is just tied to one account, there's a little bit of an issue, right? Because I know where it's coming from, so I can easily kind of link that. But if my balance is basically sharded across the entire state into little pieces, then this kind of like adds some layer of obfuscation for what would get spent and what is spent. And in like Zcash and Monero, they have these kind of like decoys that they throw in to kind of like really kind of say, well, which of the inputs will we actually even spend? Well, it's not all of them. So there's little games that you can play that definitely slow down performance, like any kind of security thing.
Sure.
But it is really kind of like a base building block in the kind of the ZK paradigm. So anyways, that's all I want to say.
Yeah, what's the triangle again? It's like speed, security, and functionality. It's like choose any 2.
Right. Yes. I mean, that's generally the overarching paradigm. You spend more time, you can make it more secure.
Right.
Not always, but kind of general sense.
And if you want something that's fast and secure, well, it's not going to do very much.
I wanted to bring the ZK thing back to the cubby analogy. So if you think about the way storage works in account system, it's there's one specific cubby that's for my balance and one for Lawrence and one for Aaron's. And so you can imagine making it like a little bit ZK by saying, okay, we're not just going to throw our cash in there. We're going to like throw our cash inside envelopes, or like, you know, what that means is like encrypt the amounts, the balances. But the thing is, if I want to send some money to Lauren, sure, maybe nobody knows how much I sent, but they can see that this transaction like affected my cubby and it affected her cubby. So that, you know, maybe we did a little better by hiding the amount, but it's really still pretty linkable. It still leaks a lot of privacy. Absolutely. But if you think about the UTXO model, where no cubby is inherently associated with any individual person, in fact, the cubby addresses are based on like the hash of the transactions that uses them, then it doesn't leak anything in that way. Yeah. And so both Zcash and Monero, even though they differ in many important ways, what they have in common is that they use UTXOs for privacy.
Okay, cool. Yeah. And I can see why.
Yeah, cool. Okay, shall I take over with the order book? I'll do this part. So we mentioned that some applications fit better in the accounts model and others fit better in the UTXO model. It's often the case that whatever thing you want to whatever thing you want to build can be built using accounts or UTXOs, but one is kind of like a more natural fit. And so to give an example of one, I want to talk about DEXs, or decentralized exchanges. So let me get my speaker notes back up. Here we go. Well, I guess first I'll say like centralized exchanges like Kraken or Poloniex or whatever have existed for years and years, since like Mt. Gox basically. And they typically operate in this way called an order book. And the way the order book works is that customers place these things called orders, which are agreements to trade some tokens for other tokens. So for example, I place this order that says I want to buy 10 ETH and I want to pay, you know, however much USDT for it. And then it sits on the exchange for a long time or maybe not very long, but some amount of time, until a counterparty comes up and sees that order and places an order that's the opposite, where they'll basically do that deal with me. And maybe there'll be a little bit of a difference where I paid more than the other person had required. And so the exchange takes some profit there. So that's an order book where customers trade directly with each other. You sort of match buy orders and sell orders together. So centralized exchanges, you know, centralized services suck for a whole bunch of reasons we don't need to go into right now. And so it's cool to move the exchanges on chain and make them decentralized. And so people did this, like they're all over Ethereum. But the ones that are on Ethereum are typically not order books. They're not the kind I just described, because an order book is hard to build in an accounts-based system. And a much more natural thing to build in an accounts-based system is an automated market maker, or like a liquidity pool, like the Uniswap kind of thing. And so this is an example where if you want to build an AMM, you should probably use Frame. You should probably use the account system. But if you want to build an order book fits perfectly with the UTXO model, whereas an automated market maker is really, really clunky in the UTXO model. And just as an example, so Cardano is probably the most popular UTXO chain that does anything more than just cryptocurrency. And when they first enabled their contracts, there were a few different dApps that were basically Uniswap style AMMs written in Cardano's UTXO-based language. And they're really, really hard to use. And this is why. Think about one cubby that contains the state of the liquidity pool, like how many of all the tokens are in it and what the ratio is and all that kind of stuff. And then imagine that like around the same time, Andrew and I both want to make a swap in that pool. So we both construct our transactions and we say like, okay, take stuff out of this cubby that has some of my tokens in it and this cubby that has the state of the entire AMM and run this transaction and then put back the new state of the AMM and my new tokens. And imagine Andrew does that same thing about the same time. Well, now we're competing over the pre-state of that AMM, and whoever's transaction gets first makes the other person's invalid. So then they would have to send their transaction again with the new post state. And, the busier it is, the harder that becomes, either for humans or for their wallets.
Sure.
Yeah. So, okay. So the example we're going to talk through today is an order book based DEX, and AMMs are very interesting too, but we're not going to do those on UTXOs.
Absolutely. Yeah. That's a whole other topic for a different day.
Yeah, exactly. So, okay. So here on the slide, I just kind of made up this JSON schema that represents an order. So you basically say like what side of the deal you're trying to take. So you could interpret this as like the first order is trying to buy 150 of token A, and they're willing to pay 200 of token B. And then the second order, they're trying to sell 160 of token A, and they're willing to pay 100 and they want to get in exchange 190 of token B
for it.
Yeah, for it. Exactly. And so this is a buy order and a sell order. So that's good. And these orders actually match because the sell order 160 covers 150 and 200 covers 190. And there's actually like 10 extra of each token left over. If I were someone watching the chain and I saw these two orders come in, I could say, hey, I have an idea. How about I like make these two order people happy by giving them exactly what they asked for, and then I just pocket the 10 of each token that's left over. And so that's a matchmaker. And so the way that our order book is going to work is that there's basically two transaction types you can send. One allows you to make an order, and the other one allows you to match two orders together. So that's the core of the order book model. And I linked this article here that I won't click now, but it goes into a whole lot of detail about the differences between order books versus AMMs. And it was a pretty interesting read.
Nice.
Yeah. So just to say, I want to just get people familiar with order books. This is really tangential to Tuxedo, but it's the thing we're going to hack on. So like you can't build an order book if you don't understand how it works. So just bear with me as I explain it a little bit more. Sure. So this is a screenshot that I just grabbed from like DuckDuckGo images. I don't even know what this DSC coin is, but this is showing an order book. It's a visual representation of an order book between this DSC token and ETH. And the green part is the buy orders and the red is the sell orders, or maybe vice versa. It depends which way you think of it. And we're stacking them up a high bar, like over here on the left where there's a high green line. That means there's a lot of people willing to do a deal at that price, and same thing on the red. And then as you get closer and closer and closer to the middle, closer to a fair market price, there's fewer and fewer people willing to sell their tokens for that like right at the fair market price. There's a lot more people willing to say, sure, I'll sell my ETH if you way overpay for it, and not as many people saying, yeah, I'll sell my ETH like right at market price.
Yeah.
And so if you're the kind of person who wants to be matchmaking, that job that I just described where you find orders that can be paired together, this is what you want to do. You want to sort your order book into something like this. And the moment that the red and green regions overlap each other, those overlapping transactions can be matched with each other. Overlapping orders, I should say.
Yeah.
I wonder what happened with the the big spikes in the green, where it's like sudden like drops or jumps, whatever way you want to look at it.
Yeah, some whale was really willing to sell a lot of tokens at this one price, I guess.
Right.
Yeah, some big order there. So, yeah, and I guess one other thing I'll say is that it's a classic property of the UTXO system that what seems like a lot of computation here is shoved off chain and onto the client side. So we never have to sort the order book. We never have to make this like ordered VEC on chain. All we do on chain is have a bunch of cubbies that have orders sitting in them. And then people who come along and match and take those orders out and give tokens back.
Yeah.
All of this sorting happens off chain by someone who's trying to be a matchmaker and is following the chain and indexing the data in such a way that they can make matches.
Okay.
So the heavy part is off chain, is the point.
That's cool.
There.
Yeah.
Okay, so the core, these are like the actions that you could take in an order book. So there's two core ones. These are the ones we're going to implement or look through the code where I implemented and maybe re-implement. We want to be able to place an order and we want to be able to match two orders together.
Sure.
Some nice ones, it would be like cool to have these if we wanted to. One is to cancel your order, to say like, I'm not in the mood for this trade anymore, forget about it. You can kind of work around this if you have some open order and you want to cancel it by like opening an order that's exactly the opposite and matching them together so you keep
yourself.
all your own tokens. Yeah, just trading with yourself. But even it has some problems. Like you can imagine if I make this order that says I'll trade 10A for 1B, and then I want to, so I put up the 10A collateral with it, and then later I'm like, I want to cancel that, but I don't have the 1B to cancel it. So it's not perfect, but a production ready order book would have this, but we're going to try to stick to the core.
Sure.
And then the second one that I said would be like an enhancement is take order. And take order is basically like an atomic action for both of these put together. So imagine you see some order sitting there on chain in one of those cubbies and you say, ooh, that seems like a good deal. I would like to take the opposite position of that deal. Well, of course you can like place your order and then separately submit a transaction to match them together.
Sure, but
take order would just be a convenience to do it atomically.
Nice.
Yeah. And then the final ones that I have here, we're not going to go into how to couple our Tuxedo pieces together yet. So if we wanted to work with this, with real transactions from our wallet, we would need ways to like mint token A and token B, because we're just going to have our tokens be native to the DEX.
Okay.
So yeah. So anyway, like I said, we're gonna make these main two here today, and so let's just like look into the Tuxedo architecture a little bit, and then we'll dive into the code. So here's our links again. We have I almost said really good. Let me not like oversell it, but we have Rust docs. We do our best to keep them like thorough and useful. And then here's our GitHub repo. So as I should say the call to action today is that I hope people think Tuxedo is interesting and try to write runtimes with it. So as you're trying to write your runtimes, that's your homework. You can reference our Rust docs and our GitHub repo.
Yeah,
so I just want to tell you.
If you're watching in the chat, I would love to hear if this is something that is curious to you, if you are considering giving this a shot, or you need more convincing at this point.
Yeah, Manta, are you there?
Okay.
Let's look at a few of the key transaction types here. There are key types. Yeah. First one's transaction. Okay, so a transaction. In each transaction, you consume some inputs and you produce some outputs. And both the inputs and outputs are basically UTXOs that are coming out of those cubbies or going back into the cubbies.
Right.
And the thing that you specify here, this checker, this is your constraint checker. This is analogous to Frame's call enum. This is where you specify which piece of logic you want to use in order to confirm that this transaction is valid. So in the case of our DEX, there's two that you can choose from. There's make order place order or make match. So it's
some weird looking
types. This is Rust. Yeah, I got it. All right. So here's the verifier trait. So you can see our transactions generic over two things. It's generic over a verifier and a constraint checker. So the constraint checker I talked about a little bit. It's the thing that's going to check whether this transaction is valid. And then the verifier is applied to all of the outputs. So every new output you make gets a verifier, and the verifier is the piece of logic that determines whether that output is allowed to be spent on its own.
Okay.
So to give an example, the most common kind of verifier is a signature check. It's often the case that if you own some token or some NFT or whatever it is, you'll say, no one else can spend this. No one can spend this until they sign with the proper key.
Right.
And that's, I would say, if this is the first pass, you can almost think of the verifier as like making sure it's signed, but keep in your mind that does generalize, and you can get a little bit interesting. And so when you're writing
be a signer.
What was that?
It doesn't have to just be a signer.
Yeah, that's right. It could be proof of work, or we have one called up for grabs, which means that anyone can consume this input, no proof at all necessary. So, or Andrew just wrote one that's like a multi-sig, for example, that requires multiple signatures. Yeah. So, okay. And then finally, the constraint checker. And basically what the constraint checker does is it takes all of the inputs and outputs in your transaction, and it executes some code that says what, excuse me, says whether or not it's valid. And then if it is, it returns a priority for that transaction.
Okay.
And I would just throw in, and we'll probably talk, but if you notice that the output is generic over the verifier, so you could really think of the verifier as like a guard to spend.
Yeah.
It's what needs to be verified before this thing can be consumed in some way.
For sure.
Yeah, that's a great way to think of it, as a guard. Good point. So as a concrete example, if we were talking about a cryptocurrency, this constraint checker would basically add up all the input values and add up all the output values and make sure that the input value exceeds or is equal to the output value. So make sure you didn't print any money in this transaction. In our DEX example, the one where you make an order will basically make sure that you're putting in enough money to collateralize that order. And then the matchmaking one will confirm that the orders are compatible and there's enough of each token available.
Sure.
So that the inputs there, that's like, or that's actually should be outputs because it's the previous outputs of.
Yeah, so this is not a typo. Yeah, where you might think that should say inputs has type slice of inputs, but it really is a slice of outputs because it's the outputs from the previous transaction that created them.
Yeah.
Yep, that's exactly right. Yeah, and if you look through our Rust docs, you'll see, there is this type called input that I showed somewhere, I think. Yeah, right here. So what all an input is, it's basically like a reference to which cubby the output should come from. And it's some kind of proof that satisfies the verifier. We call it a redeemer, basically. So for example, it's like the valid signature.
Okay.
Yeah. So once you've confirmed that the signature was valid or that the verifier was successfully redeemed, and once you've looked up that old output out of storage, out of the right cubby, now you get something like this where it's outputs on both sides.
Okay.
Yep. And then the last thing I'll show here is this simple constraint checker trait, which is quite similar to the constraint checker, but the types of the input data are different. Mm-hmm. And basically here, we're just not passing in the verifiers. And the idea is basically that in many cases, you don't need information about the verifiers to determine whether the transaction is valid or not. And so we just provide this convenience trait so that you don't have to mess with all that unnecessary information. In other cases, you do need it, and then you use the full trait.
Sure. But you can, decide.
Yep. So, okay, tuxedo pieces. Yeah, we're getting close here. So tuxedo pieces are analogous to frame palettes, basically. If you think of a tuxedo like a suit, you have like a 3-piece suit or 5-piece suit or whatever. So that's why we call them that.
I was literally going to ask, like, are you going to start naming different parts of tuxedo after the different pieces of a tuxedo? It's like, okay, so this one's going to be bow tie. This one's going to be waistcoat. This is going to be jacket.
Do you think we should? It crossed my mind.
Yeah, we should.
Yeah, I spent yeah, good. Keep the names coming. I spent like an hour when we were starting this trying to find like a very esoteric vocab word that would mean like a piece of a tuxedo that wasn't just pieces, but I couldn't find one. I just went with pieces.
Yeah. Right.
There will be something. There has to be. Like,
I mean,
yeah.
Do you have any feelers in the chat?
Yeah. So when you're writing your pieces, it's kind of similar to writing a frame palette. Basically, you're going to write a collection of data types. Maybe you won't need any data types, but probably you will. We're going to need one for like an order, for example. Yeah. And then you write your constraint checkers, and that's pretty analogous to writing your extrinsics when you're doing like your frame calls, I guess, the palette calls. Yep. And then sometimes you even write some verifiers. That's less common. Usually people get by with SIG-check and multi-sig and those kinds of things, but totally possible to provide your own, and you can get as creative as you want with the verifiers. And then I guess something that I didn't write here is you'll also define your own error type so that your constraint checkers can give more information about what went wrong when they find that a transaction is not valid.
Nice.
So, okay, I guess I'll talk about aggregation here. If you're familiar with Frame, you know that you synthesize all these palettes into one outer runtime, and aggregation works similarly with Tuxedo. So we have two different things that get aggregated right now. One is the verifier and one is the constraint checker. So you think about all these pieces providing verifiers and constraint checkers, we aggregate them into these enums that have one variant for each piece. I'll say it looks different than Frame because in Frame you call construct runtime and it creates all of these outer things itself. They have like the outer call, the outer error, and some others that I can't think of that all come from construct runtime. Yeah. And in Tuxedo, it's a little more transparent to the developer exactly what's happening because you're creating each one of these enums yourself. And it allows you to, for example, like use a constraint checker from some piece, but not use the verifier that they shipped with it. Maybe it was optional. Or like when we write our decks, it would allow us in our test chain to use those constraint checkers that allow us to mint token A and token B. But then maybe in our production chain, we don't aggregate those specific constraint checkers in, and we only leave the serious ones about making orders and matching them together.
Cool.
Yeah. So I just linked the rest docs for our aggregation macros there. They seem to be working well. They're pretty new, and I'm kind of a noob with proc macros. So if anyone in the audience wants to get involved and is good at macros, that's a great place to go.
Great call to action. I love that.
Yeah. And speaking of that, we do have an issue queue with, some 15 or 20 issues.
Yeah. Do we have any that are marked for like good first issue for someone who's jumping in?
They're all good first issues.
They're all good.
No, that's probably not totally true. We haven't marked them, but if seriously, if someone's interested, we would be happy to point you at the right one based on your
very cool
skill set. So, okay. And here's the executive type. So this is named after the Frame executive. I'm just going to actually show you the rest docs because I didn't type them all back into the slide. So it has a bunch of functions, and I want to show you these ones first. There's one called apply extrinsic. Does anyone recognize that function name? I mentioned it earlier. It's in the block builder API. And then there's also execute block, which was in the core API. And here's validate transaction, which I didn't mention explicitly, but it's in the transaction pool API, which is one of the other ones that I glossed over. So the executive is the thing that comes with Tuxedo Core that implements all the runtime APIs for you.
Great.
So since the runtime APIs are implemented for you, what we're trying to do is reduce your risk of, wait, let me get my right tab back. Oh, where'd my slides go? Oh, I lost it because
you navigated away.
I clicked the link. Yeah.
There we go.
So, yep, there, got them. So I just am trying to say, where's the slide? I think it's this one. Yeah, there we go. That because the executive implements the runtime APIs for you, that's how you are more likely to get something that looks like this or like this than something that, looks not production ready because you did it by hand.
Right.
So that's the idea. Now, I'm not trying to make the claim that Tuxedo is like 100% production ready yet. We've only been working on it like a month and a half, but that's the goal basically, is that individual developers don't have to go down to the runtime API.
Yeah, don't have to be doing that. Okay.
So, all right. So I think we're ready for a code walkthrough. That was going to be my next slide. So let me just make sure. Yeah, code walkthrough. Okay, so I'm gonna
just remember to show the node very briefly.
Only to make.
Yeah, right, right. Yeah, he's making fun of me because I have my notes to myself right on the slide here. I need to stop my screen share and I'll start it right back up. So just give me 1 second.
Sure.
Here.
What do you want to talk about until then?
One thing we didn't mention, which we'll probably show. Sorry to make it more nerd talk. There's no fun and games here. is that we've been talking a lot about UTXOs as coins and like bills and how you're going to spend them, and it's money. But what is different about the extended UTXO model that we are basically mimicking from IOGK is that the inside of an actual UTXO, it's not just a value like a U128, it's just an arbitrary vec of bytes. And so we're going to show you how you basically define what data you're going to store in it. So when you're actually starting this, which we're going to go through like kind of a hack session, you think of it, I think, kind of similar to when you're building a palette in a lot of ways, is you kind of start, at least the way I do, is from what am I storing? Like what do I actually need to keep track of? And then I write the extrinsics for how I want to mutate this thing. And so it should mimic that in some ways to think of, you kind of have to think about what you even care about storing in the first place.
So back to that question that we want to empower developers to be thinking through in that kind of design phase where they're making these decisions. What are you storing? What's important to you? And to make these decisions to create the best possible runtime for you.
Right. And so in money, maybe it is a U128, but in terms of maybe it's something, it's just an arbitrary struct that has some meaning to you in your application.
That's a good place to dive in the code. I think that's a perfect place to start. Is my screen share up?
It's not. We can pull it right now.
You're good.
All right. So this is the Tuxedo repo. I'm in the Tuxedo core folder. Here, maybe I'll do that.
Perfect.
And I'm in this dynamic typing file. And so Andrew was saying for any type that you want to be able to store in a UTXO, or like any kind of thing you want to be able to jam into one of these cubbies and state, you have to use this dynamic typing library, because the idea is Rust is strongly typed. That's really great. We love it. That's how our Tuxedo code is too. But when you go to write something into storage, you're just encoding raw bytes. And you want to make sure that when a later transaction pulls the thing back out of storage, it decodes to the same type that it originally was. And the risk is really subtle, but you could imagine having like some NFT and spending some trivial amount of money to like get it just the way you want it, so that you can store it and then later read it out of storage as like a Bitcoin, and it happens to decode as a really high value Bitcoin. So that's the whole purpose of this dynamic typing library, is to avoid that. And then what Andrew was saying about defining a data type that you can store, basically all you have to do is implement this trait, this UTXO data trait.
Okay.
And so you give it this 4-byte unique type identifier to do so. So it's let's look at a few examples of that. Actually, I think it's probably more intuitive. We can look at money first. So this is our cryptocurrency, our Bitcoin-like thing. And I'll start at the top. So here we have our money constraint checker. And it's going to have two variants, spend and mint. So it makes sense. This is the one for making new coins, and this is the one for actually like sending them around. This would be kind of a development one, like we were saying with our DEX. Okay, and here's our data type coin. So like Andrew said, a coin is pretty simple. Maybe it's just a U128. And so in this case it is. And then here we impl that one type that allows us to store it in storage, and we just give it this type ID coin.
Yeah, got it.
Yep. So here's where we impl our actual constraint checker. Oh no, sorry. This is the errors. This is all the things that can go wrong when you're checking constraints with money related transactions. And this is really analogous to Frame. I guess the only thing is there's no macros needed on it this time. We tried to make the macros approachable.
There is macros, obviously. We can see on 53 through 57.
Oh,
but
we
don't have the palette macro or anything.
Right. Yeah, no macros except for these 12 that I details about. No Tuxedo related ones.
Yeah. So yeah, this should feel analogous to Frame.
It definitely does.
We were thinking in terms of that. We don't want to make it so different.
No. I get that.
Let's see. Okay, so here's where we actually implement the constraint checker. And so there's a whole bunch of different ways you can do it. You can have one constraint checker where you match like this, or you could have one constraint checker for minting and a separate constraint checker for spending, and then you just impl the trait for both of them, and it's just a matter of personal style which one you do. So I had mentioned previously that we basically just make sure that the input values are less than the output values, and we do that just by iterating through and adding them all up. And yeah, you know, there's a bunch of things that could go wrong about overflows, or we don't allow users to create outputs that are worth no money at all, because that would just be a waste of chain space. So yeah, and
so
then if we make
like,
it, go ahead.
Yeah, this constraint checker is, if anybody's thought of the logic of Bitcoin before, it's just going to look very similar in terms of like what we're trying to verify here, which is just that the sum of the money is, you're not printing more money out of nowhere.
Yep, exactly. And so the APIs allow these constraint checkers to tell the transactions, or to assign transactions priority. So we can see here, like, we let the number of tokens that are being burned equal the input minus the output. So like, let's say I put in a coin that's worth 10 and a coin that's worth 5. So that's a total of 15. And then my only output is a coin that's worth 12. So in that case, it means I'm burning 3 coins because my inputs exceeded my outputs. And so what we do is we treat those burned amounts as like a tip, you know, an incentive to get higher priority transactions. And so we take the amount burned and we return it as the transaction priority.
Got it.
Yeah. And then we just, this whole business is just because priority is a U64 and our coin type's a U128. So we have to kind of saturate it. Nothing too fancy there.
Sure.
So while we're in money, this is something that I really like to point out about Tuxedo. This is one of the things that makes Tuxedo nicer, in my opinion. And there's a whole bunch of things that make Frame nicer, and I'm just not my job to point those out. I'll just point out the ones about Tuxedo.
Well, no, and we're also like not pitting them against each other too. I think exactly. Super clear.
Yeah, it's in the same way that you wouldn't pit like a hammer and a screwdriver against each other. They're like, many projects require both, or they work together well, or whatever. Yeah, 100%. Complementary is what I'm trying to say. So here's the thing that I like. Here's one of the things that I like about Tuxedo. When you're writing, because all of the state is local, it means I don't know what cubbies to go out and grab state from, even if I wanted to. It's not even possible. Instead, all of the relevant state is already pulled out of cubbies by Tuxedo Core, and then just the data itself is passed into your constraint checker. So when you're writing unit tests for your constraint checkers, you don't have to deal with like test externalities and setting up storage and building the test externalities and all of that stuff, because there's no storage related operations at all happening inside your pieces. They all happen in Tuxedo Core. So you don't have to deal with any of that SPIO related stuff at all.
Yeah.
So, yeah. All right. So let's see. Wow. This seminar's flying by. I almost, Andrew, do you want to talk about kitties at all?
So I guess we
should a weird from sentence.
Yeah.
We're running out of time. So what's your favorite animal, Andrew?
So we basically we put together a bunch of different pieces, which are now, I guess, the pallets. We first did the money, and we have various different ones. There's an amoeba. I did a kitties one. But essentially, I guess the one thing I'd like to show is maybe just like the data that's stored. So we talked about the money.
Let me find it.
I was busy reading the story at the time.
Yeah, so you have this in the case of the kitties one, there's this much more abstract, or like there's a lot more can be captured here in the data. It's not just a U128. There's this parent, which is a variance. There's there's some thoughts of breeding for money, which is and then there's maybe a piece of DNA, and what is that represented? So this kitty data is what would actually get stored inside of each output. And so it doesn't have to be, like I said, this is kind of the flexibility, is you're going to define your type, or what you're going to actually store and manipulate. And that kind of allows you to have some level of, diversity and rich state, which is what we're kind of going for.
Yeah, I think that shows that well.
And also shows as well that like Joshy has a spell checker installed in his VS Code extensions, and Andrew does not, is what
I don't.
I was trying to decide if rearing should be added to my dictionary.
Oh gosh.
But I guess if you just scroll down a little bit, there's an error type again that has a lot of stuff. I have this breed trait, and it does a lot of different checking, right? It checks the mom, it checks the dad, or no, because when you're developing this thing, it's kind of interesting is that you normally when you're doing the frame thing, you just check your input, right? It's like, what am I getting in? Is this valid to operate on? And in this case, you have to check also what's going on with your output. And so this is that part throws you a little bit for a loop as a developer, because normally you just kind of like verify what's coming at you, and then you can just operate on the data as you please. But in this case, you have to think of all the different ways someone could trick you. Like I guess we talk about in development of blockchains and blockchain applications, that security is one of the things you think about the most.
Yeah.
And there's some being defensive in this terms requires you to really kind of take a step back and think about how someone could produce some input that would give produce some kind of malicious input that would give a valid output, or also some valid input that can give some kind of like invalid output. So both of those are true. And so anyways.
I will just side note, pedagogically acknowledge, I think it was smart to start with the money as it's showing that, walking that through simple, straightforward, and then going to kitties and then like almost like highlighting all the different things you need to be thinking about or could be. Yeah, I think that works.
Yeah. So really just in this application, you have some parents, some mom and dad, and then you can get a family out of it, of a mom and a dad and a kid. So, it's just your typical breeding type scenario. But just to, again, reiterate the arbitrary state that you can store.
Yes. Yeah. It highlights.
I see some laughs from Joshy.
No, just talking about breeding. A lot of talk about breeding.
Yeah.
Also, like,
I can't wait for the clips.
I know.
What's the max value for a U128? Because I saw that was like the max number of breedings was being stored as that. That is one unfortunate cat.
Yeah, a lot of breeding there.
Hey, so it could be a
I'm not.
Sorry.
You're not touching that one.
I'm gonna get back to business because I'm gonna cram everything else into 8 minutes. Sorry,
all right.
gotta fit it in. But I wanted to show the high level structure of the repo a little bit, and there's kind of 4 main folders. And so the one that I'll start with is Tuxedo Core. So this is what Andrew and I develop, and your contributions are very, very welcome. But as a runtime developer, you're likely not going to have to hack in there, or at least our goal is that once we have it fleshed out enough that you won't have to hack in there. Instead, you'll have this Tuxedo template runtime, which is a lot like the Substrate node template runtime. Yep. That's the one we were just showing you, that you can just fork and change that code yourself. So that's 2 of our folders, the Tuxedo Core, which we wrote, the template runtime, which anyone can fork and write their own runtime. Then there's the node. I'm only going to show this one very briefly, Aaron. This one is a copy of the Substrate node template, a character for character copy, except that we fixed all the Clippy warnings that were in it. And so the point being, we didn't have to modify the Super Nintendo at all. All of Tuxedo's work is inside the runtime, inside that WASM blob. And so the same original node works exactly as it did. And then the 4th and final folder that I want to talk about is our wallet folder. And the wallet is an interesting application, and it was a little more involved to write than I expected. And it's because of something we talked about earlier that I think Lauren had asked about, which is how do you know about all the UTXOs that are relevant to you? And so what we did in the wallet is we have the wallet with its own local database. And every time you start up the wallet, it communicates with the node and says, hey, node, here's the best block I know about. Is this block still in your main chain? And if it is, that's great. The wallet just syncs all the rest of the new blocks that the node knows about and checks for any relevant outputs to index. Or if the wallet finds that its block is no longer in the main chain, if it got orphaned off, then it will roll back or unapply blocks one at a time until it finds one that is in the node's main chain. So like the common ancestor of the fork, and then it'll resync from there.
So does that mean then that like light clients can't be really a thing with this model?
So no, light clients can be. So this wallet is happening from an off-chain perspective, but the light client can still run I mean, I think as soon as we have a light client that supports Substrate in general, then this one should work. I haven't thought about it a lot. Yeah.
Yeah, this is just how you'd sync. Like we do this kind of manual interaction RPCs with a full node that's local because this is kind of where we're at. But yeah, eventually then we have the wallet running as like a kind of a trustless thing inside of. You know, one thing is that the wallet is actually pretty difficult because we can't just use the Polkadot.js extension or a lot of the Substrate wallet stuff. So if anybody is curious on developing wallets and likes to do that stuff, it's actually a lot of fun, and it's quite different in the UTXO paradigm because also we don't have all the RPCs from Polkadot.js, so you really feel the work that's been done on Substrate so far. So if anyone's interested,
I remember battling that in the frameless assignment as well. Being like, oh, so Polkadot.js is just broken. Awesome.
Yeah, exactly. You know, as a Tuxedo developer now, I was thinking back on that assignment, and I was thinking about the title that we gave it, the frameless runtime. It's actually like a little bit of a microaggression to us Tuxedo folks because it's like, oh yeah, all the runtimes are frame. This one's frameless. Next time I'm going to push to have it be like the runtime from scratch or something, like runtime without any framework.
Sure.
So, yeah. So okay,
and then that's the moment that they can choose that you can introduce that, and it is a a greenfield landscape. Like, sure, go this, like, here are your options. It just feels empowering, I feel like, to know and not feel forced into something.
So first student to submit their assignment using Tuxedo in the frameless runtime, or whatever we want to change the assignment into, is it automatic pass?
That's
or
cheating.
like
That's cheating.
I mean, you'd have to talk to the grader, but I just happen to
No.
know who graded those.
No. Okay, whatever.
Just kidding,
Regardless,
just kidding.
there's some good call to action that you've shared about. If folks are curious about wallets, like, that's a great place to reach out and get involved too.
So I want to try to do a little demo here where we just run our node, and let's just see what happens. So it might be a familiar command if you've ever used a Substrate node. Remember, the whole CLI and everything is on the client side. So nothing about switching from frame to Tuxedo changes any of that stuff. Cool. And you can even see like the log messages look, identical.
Very familiar.
Basically. So that's just a Substrate node running, and whatever's happening in the runtime, we don't know yet. We definitely can't hook up Polkadot.js though at this point. We have to use our own wallet because we don't have any of the normal frame structure or anything. So, let me see if I built that, but if not, it's not hard to build. There we go. So let me make this a little bit bigger.
Thanks.
The way the wallet works is that every time you start it up, it will sync with the chain, and then it will exit, unless you give it a sub command. And if you give it a sub command, it'll start up, sync with the chain, and then do whatever it is that you had asked it to do. So let's just experiment with a few of them. So I should be able to like target, debug, Tuxedo template wallet. Well, let's just do that first of all. Oh, great. Okay. Yeah. Genesis does not match expected. So what happened here is that this wallet already has some data in its database, and it's from a different chain. So I just have to clear out that data real quick. So let me just do that. That's in
I had a script for this.
Yeah, good. You should. All right, let's try again.
So helpful.
Dev, you want to do dev, by the way.
On my chain, I did do dev.
On the chain,
That's right. We're on the wallet. I forgot.
Yeah. Okay, so what it told us this time, initializing fresh sync. That's great. There were no blocks in the local database when it started. That's consistent with fresh sync, and it synced up to height 32. And now that it's run, a few more blocks, like if we run that same thing, we sync from 32 to 40. And like if I run it fast enough, there we go. There was like no resyncing in this one. Cool. But let's just do let's do a sub command here where we just like show balance. So it shows us that there's one account. This happens to be like the test account. and it has 100 tokens, and all together that adds up to 100. And then we also can do this thing where it shows us the entire contents of the cubbies. It's called show all outputs, I think. And I should say, when I say the entire contents, I mean the entire subset that our wallet cares about. So coins that belong to this key. Yeah. And it shows us there's a single output. This is its ID. This is like what cubby address it's in. It's only special all zeros because it's like the Genesis one. Normally they look like noise, you know. And it's owned by this person for 100. So what I want to do then is just like spend this thing. So let's do I think it's called spend coins, and we'll let the wallet choose whatever coins it wants. One thing that's nice about our wallet is it can auto select coins that add up to enough. If we wanted, we could do -I and paste this exact value to tell it like exactly which one, but it's capable of selecting its own. And we'll just say like the output amount we have 100 to work with, so we'll split it to 50 and 40 and 5, and then we'll burn the remaining 5. And then we could do like recipient, but we'll just let it go back to our default account for now because we're like out of time. So, whoops. What happened here? -040 and -05 output. There we go. Okay, so now if we do show balance.
I was kind of wondering, I was like, do you have flags set up for every possible number that you could send?
No, yeah, it's just a typo. That would be ridiculous. What a terrible CLI.
But, I mean, maybe a little bit of a like easier way to do that.
Yeah. So we can see our balance is down to 95. That's because our last transaction, burnt some. And then if we do show all outputs, it tells us about these same outputs that it created here.
Cool. Yeah.
So, okay, so that's it for the demo, just because we're a little low on time. But I will say there's a README, and it tells you some of the commands you can run. And then there's also a README in the wallet directory, which does a much more detailed guided walkthrough of how the wallet works.
Very cool.
Thanks. And so the final thing I'll say is that I'm on this branch right now called Joshy Dex Hack. Here, I'll show it to you guys over here, because this is what I wanted to show. This is what we were prepared to do for the Dex. So let's see. There it is, Joshy Dex Hack. Here, you guys can share that link.
Sure.
And what we were going to work through, the code for the Dex that we talked about so much today is in the runtime, and it's in a file called dex.rs that you can look through. It'll be written up as a full, complete tutorial soon, and everyone can follow along.
Sounds like that's some upcoming work for the two of you then.
Yeah, exactly. That's our third milestone.
Yeah, exactly.
Judging by the number of typos or spelling mistakes in Andrew's copy, I'm hoping that it's some work for Joshy.
You're sharing the word.
Yeah, I'm done. You can stop the share here. I can stop it probably. Oh, whoops, that was my key. Yeah, good work.
Cool. Okay, well, amazing. I really appreciate you taking us all the way back to etymology of it, right, and how it got started, and then to where you are today. It's really exciting stuff. I think I understand it a whole lot better. I'm sure you do too. I don't want to speak for you, but it's exciting work that you're doing, and it feels very tangible, the work that folks that are curious and have enjoyed the code today that want to get involved and want to, I don't know, hang out with the two of you too. It sounds like a pretty fun gig. So
I think it is good as well to show that it is possible to use Substrate without FreeM too.
Yeah, I think that's the really cool thing here is that it is there's options, and we want to encourage builders to do what's best for them and to know their project well before jumping into things also, so that they are making very thoughtful, conscientious decisions, because that architecture then structure wise will be the best thing for them. So I think that is an important piece, a big takeaway for me.
Yeah, I do have one question though. I know I saw on your roadmap earlier, like, does this have then full support for like the Substrate block space? Like, could you use this in a parachain, or is that still to come?
Yeah, great question. So it's still to come. It's not a part of this first grant, but it's totally possible. There's no reason it couldn't be done. And one of the ideas we got from some of the Web3 researchers was doing like cross-chain UTXOs, where when you create a new output, you specify what chain it can be spent on as part of the verifier. then you like send that output over XCM and consume it on another chain.
Cool. Oh, that'd be awesome.
Pretty cool.
Yeah, for sure. Okay, well, wonderful. Well, thank you everyone for joining us today, and those of you who were in the chat and watching. Of course, you can reach out to us, and we have all the links, of course, as well. We'll include those in the show notes too, that people can click easily in the video recording, and yeah, get involved.
I'm glad people find it interesting. I really enjoyed it as well.
Yeah, for sure. Me too.
Thanks, Aaron. Thanks, Lauren.
Okay,
Thank
well,
you.
happy Tuesday, and we'll see you all soon. We'll see you two in Berkeley.
And we'll see everybody else next. Oh no, 2 Tuesdays.
2 Tuesdays. We're doing
Every
every
other
other. I'd like to get us down to weekly. So let's keep the content.
Yeah, the
ideas
original
coming.
seminar was weekly. I
I'm
support you in doing
Girl,
that.
I want to that's how community is built. Like, let's just be
If
with
you
each
need
other.
us to do an emergency seminar, just give us a few days notice.
Fabulous. Okay, cool. Yeah, that sounds great. Well, actually, I won't decide that. That's the whole point. I want community. So yes, yes, keep the ideas coming, and submit a PR if you have an issue that you want to see something on the next seminar. We'll see you then, though.
Thanks, everybody.
Bye, everyone.
Thanks a lot,
Bye.
guys. Bye.